This lesson looks at finding values of trig ratios. So let's take our notions of angles and triangles and apply it to a coordinate grid. So a coordinate grid, you have the x and y variables as your axes, and you have an origin, and at this origin is where your vertex is going to be attached, and your initial arm will be the positive x-axis, and your terminal arm will be the arm through which a point is passed. So in this case, you have a random point xy right here, and it has an x value and a y value, and obviously a radius, which is the distance from the origin. So these three are related in the relationship of a Pythagorean theorem, like x squared plus y squared will always equal r squared. That's one thing to note. The other thing to note that this is usually referred to theta, the Greek letter for t, but you could use any other Greek letter or even the letters you know to represent that angle. So we've discussed that in a triangle there are different ratios that can be made, and those three key ratios are sine, cosine, and tangent. In this case, there's sine opposite over hypotenuse, so if we're looking at theta as our angle of reference, our opposite is y, and our hypotenuse is r. So this is a different way of representing the ratio in terms of the portions that are given in the coordinate plane. So if you know a point, like x, y, you can find all the ratios that will give an angle that passes through this point. So what are the other ones? Cosine is adjacent over hypotenuse, so therefore is x over r, and tangent of the angle will be opposite over adjacent, which is y over x. And you can see that it's just coming from the definition of opposite being the y in this case, adjacent being the x, and radius being the hypotenuse. Now, remember that these are the three key trig ratios, or trig functions. They're also functions. But there are also reciprocal ratios, and those are coming up in red. The reciprocal of sine is the cosecant. The reciprocal of cosine is the secant, and the reciprocal of tangent is the cotangent. So if you would like to find these other three, you're just taking the reciprocal of their counterparts. And this creates the 6 trig ratios that are referred to quite frequently. Gives you all the possibilities of relating all three of these sides. Now let's take a look at this model in a dynamic environment. You can see I've constructed a graph where the angle sits with its vertex at the origin. Its x length is along the positive x-axis to begin, and the radius connects to the point xy, and y is the height value there. So this is a unit circle. So the radius is 1. It starts at 1 right here. And then as it travels up, the angle is increasing. And remember that these angles can go past 360 if you like them to, in terms of coterminal angles. And then they can go negative as well. Remember, you can add or subtract multiples of 360 to get back to the coterminal angle. But there are generally 4 positions in terms of x's and y's. You'll notice the proportion of x, y, say here, is almost the same as the proportion of x to y here, except in this case x is negative. And you can see that I've pre-calculated some ratios here which represent the sine, cosine, and tangent. As you can see, y over r, x over r, y over x, sine, cosine, tangent. Those ratios, now some of them are negative, whereas over here they're approximately the same, but they're all positive. And that has to do with the fact that you've gone x over y, in this case positive over positive, in this case, x is negative, so negative over positive, and then negative over negative, right? And I'm talking about tangent at this point, relating x and y. However, you could be relating y and r or x and r as we have. So this is kind of a visual. You see that the coordinate point right here represents the coordinate point at which it sits, the x, y, and the r, and I use these to calculate these relationships. Now the other thing is that I've shown you a unit circle, which has radius 1 at this point, but I could change this and make it, say, a radius of 2 or a radius of 0.5. So the radius could be different. However, you'll notice that the ratios are maintaining their being the same. So that reflects the fact that this angle is the same, and therefore the ratios are the same, even though the measurements are different. Now, because of that, you can see that if a point lies anywhere, now watch the xy point, if that point is anywhere along that same line, it's going to have the same proportions. So let's say we wanted to find the sine, cosine, tangent ratios at, say, this point here. Now, because this is all radius 1, the scale is a little bit smaller, but let's just for a minute pretend that these are 1s. So this would be point -4, -3 according to this grid if these were all 1. So if this was point -4, -3 at xy there, this ratio should be exactly the same as these ratios here. So how would that work? Well, this is a triangle, and we know that we can find the other parts by using the Pythagorean theorem. So if you aren't familiar with the Pythagorean theorem, you can look up the Pythagorean theorem video. But basically, when you have an xy point given, all you need to find now is the radius. Once you have that, then you can use your y over r, x over r definitions to find any of your ratios. -3 squared plus -4 squared will be r squared. So that'll be 9 plus 16 is r squared, which will be 25 is r squared, which will be that r is 5. Now the radius is always positive because of its nature. So we have x -4, y -3, and r equal to 5. Once we have that, we can find all of the ratios possible. So the sine ratio is going to be the y value opposite over the r value. So that's -3 over 5, which is actually -0.6. Look at that. Okay, now find the cosine. The cosine is going to be the adjacent over the hypotenuse, which is x over r, which is -4 over 5, which is also -0.8. And the tangent ratio is going to be the opposite, which is -3 over the adjacent, which is -4, which ends up being about 0.75, which is almost there, depending on the accuracy of the graph. So you have your 3 trig ratios if you want to find the reciprocal ratios. So instead of sine, the cosecant of theta would just be 5 over -3 or -5 over 3. The negative can be at either spot as long as it's in one, and you can find the others there. So let's take a look at this example. So if an angle is in standard position and its terminal arm passes through 5, -12, what are the values of the trig ratios? Well, all this tells us is that that's x, that's y. If you want to visualize it, that's approximately 5, -12, way down there somewhere. Great, and there's an angle there. Great, but they're not asking about the angle, they're just saying what are the values of the trig ratios. So really all you need is x, y, and r. How do we find r? Well, that's according to the Pythagorean theorem, which tells you that that's 5 squared plus -12 squared, is equal to r squared. And if you run that through, you get 25 plus 144 is 169, and the square root of that is 13, so r is 13. So since you have that, you now can find the sine ratio, which is your y over your r, your cosine ratio, which is your x, the adjacent, over your r, and the tangent ratio, which is your y over your x, your opposite, over your adjacent. So you have your three trig ratios. You can take reciprocals to find the reciprocal ratios to complete the set. What about this one? Here's your x, here's your y. We need an r, so let's go for it. Negative 2 root 3 squared plus 2 squared is r squared, giving you, and when you square this, both parts are squared, so that's 4 times 3 plus 4, which is 12 plus 4, which is 16, and gosh, don't these just work out so nice? So some of them will work out nicely and some of them won't, which is fine. You've dealt with roots before in this course. So we've got r is 4. We can say our ratio of sine will be y over r, simplifies to 1/2. Your cosine will be your x over your r, negative 2 root 3 over 4, which simplifies to negative root 3 over 2. And your tangent ratio, which is your y over your x, which is your 2 over negative 2 root 3. Now we need to fix this up, simplify it, make sure there's no root in the denominator, leaving you with root 3 over 3, and that's a negative. So there are the three values. You can reciprocate them for the other ratios. Now let's consider, rather than being somewhere random here, let's consider the quadrantal angles. So at 0, at 90, at 180, at 270, what happens there? So let's consider the y, the x, and the r at those places, and let's fill this in. So we've got, let's say, at 0 or 360. So what happens there? Well, your x is 1, your y is 0, and your radius is still 1. So in this case, sine of theta, so sine of 0, because it's now 0 being input for theta, sine of 0 is actually y over r, and y is 0 over 1, which is 0. What about cosine? Well, cosine there will be x, which is 1, over r, which is 1, which is 1. And tangent will be y over x. In this case, your x is 1, but your y is 0, so that's 0 over 1 as well, being 0. So you have those. What about at 90? So fill this in here, try it out on your own, and then check with the video for the answers. So sine of 90, what happens with sine of 90? Well, what's your x? And what's your y? And what's your r? Your r is still 1, your x is 0, and your y is 1. So now you have 1 over 1, 0 over 1, and here you have 1 over 0. So there's a problem, and at that point it is undefined. So it's really important to know that tangent has a problem at 90 degrees. What about at 180? So similarly, try it out. And we can use these calculations here to do the same process, and you'll see that the sine of 180 will be 0, the cos of 180 will be negative 1, and the tangent of 180 will be 0. Now let's see what happened here actually. Let's move back to the 90 degrees. What happened here? Because there was that undefined. Whoa, do you see that? Do you see how tangent is like a really big number at a certain point? And it gets really big, but then it becomes really negative, and it's hard to catch there. So there's actually a problem there. If I had it exactly on, it would not give a value. All right, let's continue. 270. So what's happening here? Well, we have -1 for sine. We have 0 for cosine, but tangent also has a problem here as well. So at the north and the south pole, tangent has a problem. It is undefined. So that's really important to note. You'll notice if you type that into your calculator, you'll get an error as well. Another observation that's really nice to make is, what are the signs in the different quadrants? So we've kind of alluded to this before. Notice all of these x and y's are positive. So since all three values are always positive in this whole entire quadrant, quadrant 1 is always going to be positive. And what about in quadrant 2? Well, in quadrant 2, all the x values are negative, but the y and r values are all positive. So what's happening? Well, the sine is always positive, the cosine is always negative, and the tangent is always negative. So in quadrant 2, only sine is positive. In quadrant 3, you can see similarly that only tangent is positive. And in quadrant 4, you can see that only cosine is positive, right here, the 0.8. So the cosine is positive, the others are negative. So what this leads us to is this, referred to as cast, another mnemonic for you to look at. But I mean, you can actually figure it out with the x's and y's anytime. You don't have to try to remember this, but it's an easy way to recall for yourself that all sine, cosine, and tangent will be positive here. Only sine will be positive here, others will be negative. Only tan will be positive here, others will be negative. Only cos will be positive here, and others will be negative. And this is really helpful to determine the sign of a function based on its angle. So eventually, when you see that an angle, say, lands in the third quadrant, you will know that the tangent of it will be positive, but the other ratios will be negative. So let's try to find that here. Say you know that the sine of an angle is always positive at that angle, and the cosine of it is negative. So if we look at our cast table, that actually helps us determine which parts, which quadrants theta may be in. So just by the fact that sine is positive tells us that it could be either in the all category or in the sine category. Now, because cos is negative either in here or in here. So because of that, the only overlapping quadrant is quadrant 2. So that tells you that theta is in quadrant 2 in this case. Try this one out. What if sine is negative? Well, that would imply that that's in one of these two quadrants. And the tan being negative, that's either in here or in here, leaving us with quadrant 4 as our answer. Finally, finding the values of other trig functions based on information given like this. So we can use all these tools that we've learned about the coordinate system and the angle traveling around it to find values of trig functions. So like what's sine theta, what's cos theta, what's tan theta. So here we have given that cos theta is -1/4. So based on that, it's best to just sketch it out. What does this mean? We know cosine is adjacent over hypotenuse. So you could, for example, think of this as adjacent being -1 and your radius, hypotenuse, being 4. So that would imply that your adjacent, which is the x value, because cos is x over r, you can think that way as well. So that would mean that you'd be at -1 for your x value, and your r would be 4. So you have -1 here, and your r is 4, but you don't know your y. So if we can figure out our y, then we'll be able to find the value of the others. Also, they tell us that theta is in quadrant 2. So notice that the picture I drew was in quadrant 3, but that assumed that y was negative, but we didn't actually know if y was negative or positive because we don't actually know what y is here. So I could have drawn it either here or here, right? That just by the fact that cos is negative from cast also confirms that cosine is negative here and here. So that actually reflects it exactly. The cast just reflects the signs of the variables. So if x is negative, it's going to land here. That's all it's really telling you. Okay, and we also know theta is in quadrant 2, so that means it's actually here. So what theta is implying is this angle with a reference angle right there. And so we need y in order to find the other ratios. So the other ratios that we need to find are sine theta and tan theta. But in order to do that, we need to know what y is. So we know our x is -1. We know our r is 4, but we don't know our y. So let's use our Pythagorean theorem of x squared plus y squared equals r squared to figure it out. -1 squared plus y squared is 4 squared. That leaves us with y squared equals 16, and that will be a 1, so we'll minus the 1. Y is going to be the square root of 15. So we just leave it like that, and that way we'll find the exact values. So the sine ratio will be the y over the r, and the tan ratio will be the y over the x. However, you probably want to double check your signs. Because we included this negative here, this is just going to be -√15, and it's likely that we're correct, but it's always good to double check from different perspectives. So in quadrant 2, because we know it's in quadrant 2, sine is the only positive ratio. And so sine is positive, so that's good. And tan is negative there, so that's also good. So we've found the sine and tan ratios. You can reciprocate all of these to get the reciprocal ratios. So now try this other one. So say you know that sine theta is √3/2, and you know that tan is positive. So first off, what quadrant is it in? It's easier to graph once you know the quadrant. So we know sine is positive, so that's either at all or in sine, because that's where the sine ratio is going to be positive. And we know tan is negative, so it can't be in the all section, so it has to also be in quadrant 2. Now we know the sine ratio relates the y to the r, so that's our y value over our r value, and we don't know what x is. So since we don't know x, but we know y, and we know r, we can find x. So that's x squared plus √3 squared equals 2 squared. So that's x squared plus 3 will equal 4, implying that x is 1. So since we know that, we can now give the cosine ratio, which is x over r, and the tan ratio, which is your y over your x, which is √3/1. you could just write it as root 3.